All right, the last experiment of the Green Crystal Lab is experiment 6. And the purpose of this experiment is to determine the percentage of water in your crystal. So right here I've included a picture from way back in the day, early 90s. I believe his name was Nicholas, and he happened to squirt me in the face over his shoulder with a water bottle. And that's the lovely look I gave him with my bad hair, my frizzy hair and all. Anyway, I just saw that and laughed. Thought y'all should see it. So, experiment 6, what it entails is the use of something called evaporating dishes. And these evaporating dishes are made to be heated to high temperatures. They're porcelain. They're pretty pricey, so you want to treat them with care. We want to label them not only with our names, but also marking with them with dish 1 and 2, so you can tell them apart, because the masses are really close and there's no way to differentiate unless you have them masked and labeled. You're going to weigh them. You're going to record the mass of just the empty dish. Then you're going to dump in some crystal until you increase your mass by about 1 gram. It doesn't have to be exact. And then you're going to record that mass. We will then, together as a class, put all our dishes in an oven, and overnight the crystal will dry. All the water will be driven off. And then we're going to cool it in something called a desiccator. Our lovely model, Miss Rozier here, is showing how to use the desiccator. You're going to, it's a really heavy glass container that contains something called a desiccant, that white crystal on the bottom. It's actually a calcium chloride desiccant, and it will allow the dish to dry without getting moisture as it cools. You know how sometimes water condenses on the outside of hot objects? Well, this will keep that from happening, because if we do that, that would affect the mass. So you're going to firmly grip the bottom of the desiccator, and with the other hand, you're going to slide off the top. There's something called vacuum grease all the way around the edges of both the lid and on the top of the rim of the container. So you can slide it off. I'm probably going to place with tongs, or Ms. Rozier will place the dishes into the desiccator with tongs, because they will be hot, and then you will grab it the exact same way and slide it back on. And you're going to let them cool 15 to 20 minutes. Take them out and weigh them, and this just shows you on a watch glass, you can see the difference between the dehydrated crystal and the hydrated. So this is dehydrated. So the water definitely changes how that crystal looks. Calcs here are super simple. You're going to figure out the mass of the sample, and then you can ultimately figure out the mass of the water leaving, and then you can figure out the percent. You're going to fall approximately on average somewhere around 10%. But again, it's not your percents that matter. It's did you do the calcs with the data you have. That's experiment 6. Now your final calculations, you're going to need to create a table, something like this. And this is where you set up your normal, standard, empirical formula problem. So these are the different percents that you have collected over the past few weeks on this experiment. And then you're going to pretend those percents are grams, convert them to moles. And then just like with any other empirical formula, you're going to divide by the smallest number of moles to get a number. The difference here is you're not going to then multiply at this point to get a whole number. You're actually just going to round. You're going to round to a whole number. Basically, one of your subscripts has to be 1. So that's the plan. You need to divide by the smallest and then round to the to the largest whole number. And not largest. If it's 0.5 or above, you round up. 0.4 below, you round down. And again, this is the correct formula for the crystal, but that's not what you're graded on. That column chromatography is pretty touchy. This water thing can be pretty touchy, especially if it's a humid day. So your numbers aren't going to necessarily create this perfect crystal. But your grade strictly depends on did you get what your calculations say you should have gotten. And there's no reason that you should not get 100. So on the bottom I say cheating is futile. That's true. I've had students, despite what calculations they had and what percents they had, magically ended up with this formula thinking, oh, that's the right formula, so I better get that. And they ended up not doing well in the lab. So you need to just do your calculations appropriately. And I'm trying to think anything else. The only other thing is right here, this is not a subscript because it's a hydrated crystal. You know, we always do the formula dot and then a coefficient in front of the water. It's not a subscript. All right, I think that's it. Once you're watching this, you are nearing the end of the lab. So if you have questions, please come see Ms. Rozier or myself, and we'll help you get through the calcs. Have a great day.